Hello folks, my name is Chantel, and in this video, I'm going to be showing how to instantiate VHDL statements in Active-HDL's block diagram editor. This editor is a graphical entry for HDL design, and it can be easier to use for designs that are in large part structural. It may even be easier to use this editor for creating your top-level design too. VHDL has a lot of statements that are essential to the functioning of the code, like the design unit header, architecture, and entity declarations. And the block diagram editor supports many of those statements so that you can design your VHDL-based project within a block diagram. To demonstrate this, I'm going to create a VHDL block diagram from scratch, compile it, and finally simulate it. So let's get started. I have my own created workspace and design opened in Active-HDL. And so far, the only files I have in here are a counter package and an empty block diagram file. The file counter package is a package containing a VHDL record. I'm planning to create a parameterized 4-bit counter and utilize this record. This is a bit excessive for a counter, but I'm using it so that I can show how to instantiate it in the block diagram editor. So I'll go ahead and compile the package so I can use the record. Now on to the block diagram. Up here in the block diagram menu bar are options you can click on to add objects into your diagram, like a FUB, or wires, or buses. A lot of the VHDL statements exist as their own object in the diagram. You can see here that this is to add a VHDL process inside of the diagram. And this little drop-down menu icon lets you select from a number of VHDL objects, like the design unit header, entity statements or declarations, and many more. You can also find these options by going to the diagram option while the block diagram editor is still open, and going down to the VHDL option. So I'll start off with the design unit header. Back to diagram, VHDL, and click on design unit header. And then I'm going to click within the editor space, and a light purple box should appear with the header text. For this example, I'm going to only use standard logic 1164 and numeric standard. I'll also use the package of the designs library, which I called counter, so that I can use the counter package. The next VHDL statement I'm going to add in is a generic statement. This is going to be an orange block in the diagram, and this is for a parameterized width of the counter, where I'll make it a width of 4. Now with my generic done, I'm going to add in my process block for my counter code. These VHDL process blocks will be green, and you can just double-click inside them to add in your code. Just for time's sake, I'm going to paste in a code I already made for this video. Now I want to add in my inputs. These will be the clock input and the values from the record I compiled earlier. I'll make sure I select the input terminal and connect 2 of them to the process block. I'll double-click on this pin to edit its name to clock, and I'll click OK. Then I'll double-click on this pin, change the name to control, and go over to this little drop-down menu and change it from a wire to a record. From here, I can select the record name, which should just be the counter record. And now you can see that the record's elements are listed. I'll click OK now, and notice that the input pin for control has changed into a turquoise color to indicate that it is a record type. Another VHDL statement I want to add in is a signal assignment. It should be this symbol when selecting it in this menu, and the box should be yellow in the diagram. I'll have it so that count is assigned standard logic vector count reg. The last 2 things I want to add are the bus connection from the process to the signal assignment, and the bus output from the signal assignment. I'll edit the output bus pin first, and label it count with a range of width -1 down to 0. Then for the bus connecting the process and assignment blocks, I'll name it count reg, give it the same range of width -1 down to 0, make it unsigned, and lastly give it an initial value of others set to 0. And that should be it for my block diagram. These are just some of the VHDL statements you can have in the diagram, and as you can see, there are still other statements like the generate for and if, and declarations for architecture or entity. Now I'll go ahead and generate my HDL code from this diagram. In the diagram menu, I'm going to go down to Set Target HDL to make sure that the language is set to VHDL. Then I can click on this icon, or go to Diagram and click on Generate HDL Code. In the console, I can see that my code generation was successful, and my new VHDL code is here. All of what I instantiated in the block diagram are here in the VHDL code. Here's the design unit header, then the entity declared is just the name of the block diagram, and inside of it is the generic. There's also the ports, which are the pins. See how control is an input record pin of type counter record. I didn't specify how I wanted to declare my architecture, so it's just counter BDE of counter BDE. And before the begin statement, I have the count reg bus of unsigned type with the initial value that I gave it. And then there's the counter process, followed by the signal assignment. Also notice the automatically generated comments that point out parts of the code from the block diagram. So that's the generated VHDL code. Now we'll go ahead and compile all and get a successful compilation with no errors. And now it's time to generate a test bench to demonstrate that the code coming from the block diagram is functioning. I'll go to Tools, Generate Test Bench, keep my entity and architecture as is, keep single process, click Next, skip the test vectors, Next again, leave everything as is, Next, and click Finish. And my test bench is generated. Now I'm going to make some additions to this test bench. I'll initialize the clock signal to 0, and in the stimuli section, I'm going to add my clock stimuli by going to Language Assistant, Simulation Templates, Clocking Signal, and then copy and paste the code. I'll exit the assistant, and then change the clock period over 2 to just 10 nanoseconds. Then I'm going to add some more stimuli for the rest of the counter signals. I've already made the stimuli for this video, so I'm just going to copy and paste it from my notepad. This stimuli sets the starting counter value at 2 whenever reset goes high, and I test to check if the enable and reset work as expected with the counter. Now I'll compile all again, get a successful compilation, and let's go ahead and initialize the simulation of the test bench. I'll open up the waveform view, add my signals in, and then click on Run for 200 nanoseconds. And there it is. The counter doesn't start incrementing until enable is high. The counter then stops incrementing when enable is low. And the reset did its job of resetting the counter back to 2, as you can see here, making this block diagram editor design functioning as intended. And that wraps up this demonstration on VHDL statements in the block diagram editor. Now you know about the many VHDL statements you can instantiate in your block diagram design. And with this knowledge, structural or top-level VHDL designs can be easier to create. Thank you for watching.